Today we're going to start talking about how to find the derivative and the tangent line of a given function. So first, go ahead and copy this graph and then go ahead and come back. All right, so if we're looking at this curve, right, and I have this ordered pair x comma f of x, right, so x comma y, and then if I introduce how I'm getting to my second point, I'm moving along the x-axis, so that's going to be the change in the x values, and then I'm moving along the y-axis, so that's going to be the change in the y values, right? Slope, rise over run. So how then can we get to the ordered pair for this second point up here? So now I have x plus delta x, comma, and it's going to be f of x plus delta x. All right, so that's now my ordered pair. So now what I want you to do is to find the slope using the slope formula between these 2 points. All right, so we know that slope is the change in the y values over the change in the x values. So I'm going to have f of x plus delta x, my second point, minus f of x, right? So this is y2 minus y1 over x plus delta x minus x, right? x2 minus x1. And if I simplify this, then what I end up with is f of x plus delta x minus f of x all over delta x, which should look super familiar to you, all right? Because that is the difference quotient, all right? And then quick reminder, delta x, change in x, delta y, change in y, all right? So now let's go ahead and continue. So I want you to go ahead and copy, all right, what we have here, and then come back and then we'll discuss. All right, so the derivative of f at x is equal to, okay, so we have f prime, that's what that little symbol means, all right, is equal to the limit as delta x approaches 0. Okay, so as delta x approaches 0, let's look at what that means, right? That means as the change in the x values gets smaller and smaller and smaller. So like if I were to move this point right here, and if that point were to get closer and closer and closer and closer and closer until the distance between those 2 points was 0, all right? So it's the limit as delta x approaches 0 of the difference quotient, all right? And then we have a few different ways to note that we're finding the derivative, all right? We have f prime of x, we have the derivative of y with respect to x, which we write dy over dx, and then we have y prime, so y prime. We are going to work predominantly with f prime of x and dy dx, all right? Now let's go ahead and continue on to the next page and do an example. Oh, before we do the example, go ahead and I want you to copy down, pause the limit definition of the derivative for both a graphical, numerical, and verbal example. Excellent. All right, so once you've kind of digested this, right, the derivative of a function at a point is the slope of the tangent line, right? So if I were to have some sort of curve here, let's say I had a quadratic, right? And then I wanted to find the derivative at a particular point, it would be the tangent line at that point, okay? Then, all right, numerically, right, this is the limit of the slopes of the secant line, that first line that we looked at, as the change in the x values approaches 0, right? So as those 2 points get closer and closer together, all right? And then we know that a function is differentiable at a point c, right, if the slope is defined at x equals c. And we'll kind of get more into this as we continue. All right, now let's go ahead and get into an example. So first, we're asked to find the derivative of the function by using the definition of the derivative. So we're finding f prime of x, which is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. So now what I would like you to do is go ahead and pause the video and substitute in using our f of x function and evaluate this limit. First, go ahead and come back to make sure that you've properly substituted in, and then you can continue. So first, all right, this is what you should have, all right? And then go ahead and now algebraically simplify this to find the limit. So again, pause and then come back. Awesome. So you've had a chance to work this through on your own. Go ahead and compare your work to my work and make sure that you haven't dropped any negatives, all right? And so now what we've found, okay, is that f prime of x is equal to 4x minus 3. All right, so that was how we found the derivative of the function using the definition of the derivative. All right, now let's look at part B. So part B asks us to find the slope of the tangent line at a particular point. So all we're going to do here, all right, is find f prime of the x value of -1. All right, so go ahead and pause, find f prime of 1, and then come back. Awesome. So here we found that f prime of -1 is -7. So the slope of f of x at the point -1, 5 is -7. All right. Part C, okay, is now asking us to write the equation of the tangent line at the given point in point slope form. So go ahead and think back to your Algebra 1 class. And hopefully you remember point slope form. And if you don't, it's y minus y1 equals m times x minus x1. And then go ahead and substitute in using both the slope and the point from part B. Pause and then come back to check your work. All right, awesome. So here is your equation. Another common way to write this is called Taylor form, which is when we get y by itself but still leave the rest of the function in point slope form, and we just add y to the other side. All right. Now let's go ahead and continue to our next example. All right, so again, we're finding the derivative of the function using the definition of the derivative. So we're finding the limit as delta x approaches 0 of the difference quotient. So again, go ahead, set this up on your own, and then pause, and then come back to make sure that your setup is correct, and then you can go ahead and continue to evaluate. All right, so you should have set it up and found that this is what your limit is. All right, make sure that this is what you have, and then go ahead and pause and continue simplifying. Hint, find a common denominator in the numerators, all right, so that you can evaluate this limit. All right, so now you should have evaluated the limit if you haven't paused and then come back, all right, and so this is what you should have found for this one. Lots and lots of algebra going on here. All right, so we have that h prime of x is equal to -4 over x squared. Okay, so now we can go ahead and continue, pause, fill in, and complete 2b and 2c on your own, and then come back to check your work. All right, so here are our answers to 2b and 2c. Double check, make sure you're good to go. All right, and then we're going to continue. All right, there is also an alternative form of the derivative. This is really useful when we're exploring the relationship between differentiability and continuity. All right, so here we're finding the derivative of f of c. So at a particular x value, all right, it is equal to the limit as x approaches c of f of x minus f of c over x minus c. Again, this is still the slope formula, right? y1 minus y2 over x1 minus x2. Okay, so now for example 6, I want you to use the alternative definition of the derivative in order to find g prime of 1, all right, for this given function. So go ahead, again, set this up, sub in, all right, and then go ahead and come back and check your work. So you're going to pause again. All right, so now let's go ahead and look. All right, so this is your original setup, okay? And then from here, we're gonna finish manipulating. Hint, you're gonna wanna multiply so that then you no longer have a radical in your numerator, all right? And so this, all right, take a moment, maybe pause, read through it, make sure that your work matches up with mine, all right? All right, and so what we found is that the derivative of g at 1 is 3/4. Okay, so that's what we found. The slope of the tangent line at 1 of g is 3/4. All right, now go ahead and pause the video, and I want you, well, before you pause, listen to my suggestion, all right? And I want you to go ahead and read through and complete page 7 on your own. I'm not looking for perfection here. I'm just looking for you to start thinking about the relationship between the graph of the original function and the graph of the derivative. What kind of patterns do you notice? And you're answering these questions, all right, below the curves. Once you've completed this, we're going to go over this in class. I'm not going to give you the answers to this right now, but we do have just one more page of notes for you. All right, so next page, all right, you can go ahead and pause and copy if you would prefer, and then come back. All right, so differentiability implies continuity. Star it, circle it, something. This is super, super important, okay? So differentiability implies continuity. This only works in one direction. It is differentiability implies continuity. It does not work in reverse order. So continuity does not imply differentiability, which makes sense if we look at this example here, okay? So this function, this absolute value, is not differentiable at C because the left-hand derivative and the right-hand derivative are unequal, right? Then let's look, all right? This function will not be differentiable at this particular value because we have a vertical tangent. And if we have a vertical tangent, then the slope is undefined. All right. And then the third example for when a function is not differentiable is going to be when the function is not continuous at C. Here we have a jump discontinuity, right? So hopefully this was helpful. All right, go ahead and maybe read through it one more time. We're going to go over this again next class. If you have any questions, please feel free to stop by. Have a good day, and I will see y'all next class. Bye, y'all.